It's one thing to listen to doom and gloom about food and fertilizer shortages, skyrocketing prices, the cost of living, or your job being outsourced overseas or eliminated due to automation. It's quite another thing to hear practical, immediately actionable advice from experts who can help you reduce the fear, anxiety, and burden of these problems. Tune in now to the Surviving Hard Times podcast from the Finding Genius Foundation with Richard Jacobs. Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out, and I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on current initiatives. And now to our guest. Hello, this is Richard Jacobs with the Surviving Hard Times podcast, sponsored by the Finding Genius Foundation.
I have Ole Kristian Sivertsen. He's the president and group CEO of what's called Desert Control. We're going to talk about a system that will work with and against the negative effects of climate change and desertification. The website is desertcontrol.com. So, Ole, thank you for coming.
Oh, thanks for inviting me. It's a pleasure.
Oh, great. Tell me about a bit about your background. How did you get involved with this company as its CEO, and what led up to this moment?
Well, it's a good question, and it's actually quite a story, because my background is not from the agricultural space. My background is basically from the IT and digital world. The last 8 years before this journey, I was in the more satellite services, telecommunication and satellite services business. And, what I learned is that sometimes we are too close to our problems to actually see them. So we need to get a little bit of perspective. And that's what the satellite industry gave me the opportunity to get by looking at this planet from space, from a satellite perspective, and being able to kind of put together the pieces. If you kind of like take this this planet that we live on, and you run a time warp, over some generations, to see what's actually going on to the surface and face of this planet, that gave me a strong, compelling reason to think about how can I be part of doing something with it. And without making it a very long answer, that combined with an experience and a journey I had in Africa, where I spent some time with an organization called Mercy Ships, who they were able to repurpose a Danish rail ferry into a floating hospital and providing hope and healing in places in the west coast of Africa, where basically all hope is lost if you even need basic medical help. And that inspired me so much to see how they could actually, reignite the hope in people who came there for their help and went back and changed the faith of entire villages. So on my way back to the US after that journey, I was just thinking about the combination of how hope is disappearing by the extreme degree of desertification, loss of fertile soil, and water scarcity, and sort of the ability to create hope in this world that I was inspired by from Mercy Ships. So that led to taking a jump out of very secure and promising executive career in the corporate world to doing something as crazy as joining a startup and doing something a bit more down to earth than satellites here with Desert Control.
Okay. Well, tell me, what's the premise of Desert Control? What are you guys doing?
So the premise of Desert Control is that we are a company who has set out to make Earth green again by stopping and reversing desertification, soil degradation, and water scarcity. So the innovation that we have come up with is a way to liquefy natural materials, minerals, and clay structures into a liquid that's nearly as thin as water. This liquid can be applied to sandy soils, degraded land, and desert areas, and it will percolate into the ground by the force of gravity and bind itself to every grain of sand through that loose sandy structure, turn it into a structure more like a farming soil that retains water and nutrients just like a sponge. This liquid can also be used to not just repair or turn sort of deserted and desert areas back into fertile lands, but it can also be used to protect existing areas in exposed regions, in arid regions and areas exposed to desertification. And it can be used to reduce the water consumption and fertilizer consumption for agriculture, green landscapes, trees and forests, etc.
Is it a liquid, like a liquid? No, I guess we can describe it, but it's a liquid that you spread over your land, and it's supposed to help accomplish all these things?
Yes, it is. It's a liquid that is nearly as thin as water. So you can spray it out over your land with any kind of like spraying or irrigation equipment. We are even deploying it through existing irrigation lines, drip lines, sprayers, etc. And when this liquid is applied to the top of the surface, these mineral and natural material particles and the clays that are in there, they will penetrate through the surface, even on an existing landscape. So you could basically spray it on your lawn or your farming field, and it will percolate in and go down into the root zone structure level of that soil to create this basin or this area that retains water and nutrients.
Okay. I'm sure some of it's proprietary, but what can you say about the liquid? What's in it? How does it work, etc.?
Yeah. So I mean, we do have a patented process. So that part is fine. And what's basically in it? The ingredients of this liquid is only natural materials, minerals and clays that are native to richer soils. So we have a process that liquefies it without the usage of any chemicals or any additional agents. It's pure natural minerals combined with water and air, and that's basically it. But it's processed through a very specific and patented process with equipment that we bring in on site to the property, the land or the farming field. And we process this liquid through very special processing units that we bring in, and then can apply the liquid from these units directly onto sprayers or irrigation systems.
Okay. So where has this been applied out in the field yet? How are you testing it, and what have been the results?
The idea for this LNC, liquid natural clay, also referred to as liquid nano clay, came about in 2005. Then it's undergone some 12 years of R&D and development and some field trials and testing sort of at the early stages. Then after 2017, when the company was officially incorporated as Desert Control, we've undergone 3 to 4 years of independent validation that was necessary because, I mean, let's face it, liquid natural clay, thin as water, you apply to the land and you can save 50% water and turn desert into farming land. I mean, that sounds too good to be true. So what we had to do was to work with independent validation organizations. So we've worked with the International Center for Biosaline Agriculture, a research center that has done trusted third-party independent validation of this. We work with universities such as the University of Arizona that we're currently working on similar validation studies to have this independent way of getting that confirmation of the results that we had in our earlier trials. Since then, we've been active in the Middle East as our sort of initial testing market since 2018. We've deployed this to multiple pilot projects with farms, with parks and landscape areas, trees, shrubs, date palms, fruit trees, various types of vegetables. And we're now, just as we speak, growing watermelons and bell peppers in, something that was just pure desert sand in the very south of the US in Yuma in Arizona. So that's been a total makeover transformation project that we shared quite an inspirational video of that transformation recently on our social media channels.
So in what situations would you use this, and how long does it take effect, et cetera?
Yeah. So I mean, if you have a soil that used to be healthy, that you're seeing less and less organic matter and is getting more and more sandy and dry and arid in areas with already degraded lands or sandy soils that just consume a lot of water, is the places where you would use this. You would do a one-time application, and by our experience so far, we see that has a very good duration, at least for a 3 to 5 year period. If you're tilling the land quite heavily, you may have to do a small retreatment or a top-up or booster shot after the 4th year, maybe. But those are some examples of where you would consider using it and the impact of it over time.
I mean, it sounds like you need, quite a lot of this substance. You have to mix it with water and then spray it over fields. Do you need tons of it for a given application, or how much is needed?
Well, we have a very, very unique process of utilizing the materials in a very good way. So if you think about sort of using typical clays, for example, in agricultural soil, that's something that's been, done in various parts of the world for thousands of years, I think. But you need a lot in the traditional way. You need a lot of the material. You need a lot of clay to get a good water holding capacity into a sandy soil. Reference volumes of the materials that you've been needing has been to up to 100 kilograms of clay per square meter or cubic meter of land. But thanks to the unique nano processing that we are using, we're able to actually destructure the mineral composition in a way that allows us to get the same results and even better results by using less than 1 kilogram. So from 100 to less than 1 kilogram per square meter of cubic of soil. And that's the real disruptive, unique part of our technology that also helps to make this scalable, easy to apply, because you don't need these enormous amounts of the raw materials. And as you also process it into a liquid, it's very easy to deploy it because it's a non-intrusive way. You don't need to remove the surface vegetation. It will percolate in by the force of gravity. So those are some of the benefits on this.
If, let's say, some remote farm or some place that is connected to infrastructure really well needs to put this on their fields, how would it be transported? Is it transported as like a dry powder and then mixed? Or how would it be applied, again, in bulk and transported to the site where it needs to be used?
Yeah. So we have our processing units. We have a small unit that's just basically a trailer that you pull behind a pickup truck. And we have some larger units for larger fields and larger areas that are in the shape, size of a 20-foot container. We bring that in. We bring in highly concentrated dried materials, so the minerals and the clays, so that it's easy to transport. And then we add the water that we need and process it on site and then deploy it to the fields.
So what kind of a field would need this? Does it work on just desert, or does it work on degraded fields, or where is it ideal to apply it?
It's ideal to apply it if you have a sandy soil, and lots of areas have sandy and degraded soils. In the US, if you look at The majority of Arizona, for example, is a very highly sandy soils and degraded soils. A lot of the Midwest is seeing a lot of the organic matter becoming lower and lower. So you get more and more sandy and mineral rich soils. So for the US, as an example, I mean, I would say Arizona, Nevada, large part of California, especially Southern California, New Mexico, at least half of Texas is typical sandy soil areas where this has a very high value. Of course, in the Middle East where we are, huge parts of Spain and Portugal and Southern Europe, Australia, the sub-Sahara region of Africa are typical examples where you would use this. I talked about sort of the benefit of this, of reducing the water consumption, but it's not just about the water. I mean, the problem with these kind of like degraded or sandy soils or areas and land that we have run so hard that it's getting, sandier and looser, is that the water is being lost through the soil. I mean, it's drizzling through just like a sieve, but it's not just that. I mean, on average, less than 15% of the water we apply is retained in the topsoil for the plants to use it. The majority is lost to deep drainage. And as the water washes through your soil, it also washes out the expensive fertilizers and other inputs that the farmer puts in there. That causes harm to our environment by leaching of nitrogen that goes into our groundwater systems and into rivers and lakes and eventually into the ocean. But it's also a big cost drain for the farmer, for the grower, for the landowner to lose so much of these more and more expensive inputs. So if you have a soil where you see that you're retaining very little of the water, you're washing out all your fertilizer, that's where you would consider going to a treatment such as this that would put these natural minerals back into the soil so that you retain the water, the nutrients, and you can start to recultivate and regenerate a healthy soil, build organic matter in your soil, and then create a self-sustaining, regenerating ecosystem.
So how is this going to help? What happens once you apply it? What's the time lapse and the time lag and what's happening in the soil once it's applied?
Yeah. So I talked a little bit about the liquid being applied to the surface, then it's percolating into the soil. What's basically happening is that you're coating every grain of sand throughout your soil structure with a nano-thick layer of these minerals that have an opposing charge to the water molecules, so that you will basically, just like the magnetic effect, hold on and keep and retain that water in your soil structure. Now, when you apply this liquid, it goes in to the ground, and then it's taking some time to actually form these bindings and create this soil structure that becomes more like the rich farming soil that you can shape, and turning the sand into that structure takes from the liquid is applied until you can feel this change approximately 7 hours. And thereafter, you can immediately start to reduce the water consumption, the amount of irrigation water you apply, to between 30 to 50%, a little bit depending on the soil start point and the treatment that we apply. So it's got an immediate impact to help reduce the water consumption and similarly reduce the washout of fertilizers and other inputs.
So how many times does it need to be applied, and how long does the effect last on a given bit of soil?
Our experience so far is a one-time application, will last for 3 to 5 years. If you are tilling the ground, plowing it deeply so that you're mixing in untreated soil from the deeper levels, you may have to retreat or do a top-up application after 3, 4, 5 years. But a one-time application is sufficient to get this going, and you'll have a good duration.
So do you have actual farmers that have used this, X number of months ago, and what are they experiencing if so?
Yeah, I mean, we have in the Middle East where we started projects already back in 2018. farmers and landowners and park areas that have piloted this and validated this and used this. And we're now starting to do commercial adoption as of this month in the Middle East. And then we started in March, April here in the United States in Yuma to do independent validation, a study that we're running with the University of Arizona. And in the next couple of weeks and months, we're starting also to deploy some early stage U.S. initiatives with farmers and growers in the Yuma and Arizona area.
Has anyone used this and gotten to the point where they've harvested a crop on this newly improved soil? And if so, what's the difference?
We have several data references for this for crops. We have documented water savings, water and fertilizer savings between 35 to 50%. We've also seen that when you stabilize the soil in this way, so you retain more of the nutrients and create a better soil health environment, we've documented increased yields as well between 17 and all the way up to 62% in some projects. So we've definitely seen very, very good results so far.
So what kind of application would be suitable for this, and which ones would not be? Who would be your ideal type of customer situation?
Well, I mean, an ideal customer situation is a farmer or a landowner who has a sandy or degraded soil that consumes a lot of water in order to actually address those issues. We also have, in addition to farms and the farming area, anyone who has a green landscape, parks, city parks, sports fields, and these kind of areas that also consume a lot of water, where we can actually apply it to that existing vegetation without doing any negative impact or damage to the vegetation. Trees is also an area. I mean, if you look sort of at anything from date palms to nuts and citruses and various types of fruit trees that are also very water hungry. Many of them, they actually enjoy a more sandy soil environment where you will have significant benefits of an innovation like this.
Well, very good. Ole, where's the best place for people to find out more about this, to evaluate whether it'll be useful for them?
I mean, information can be found on our website, on desertcontrol.com. We also have quite an extensive video library on vimeo.com /desert control, where you can find a lot of real world examples of implementations, how it's being produced, how it's being applied to the field, what it actually does to the soil, several reference from client implementations, etc. So those are good sources. And also by following us on our LinkedIn, Facebook, Instagram, Twitter accounts as well, you'll get a lot of updates and ongoing information about the impact of what we do.
Well, very good. Ole, thank you so much for coming on the podcast. I appreciate it.
Oh, thank you. And thanks for the great work that you are doing as well on spreading, inspiration and putting the spotlight on important topics. And I think our topic is one that is very much out of sight, out of mind, that happens underneath our feet, and it's very distributed around the world. So to get this kind of global spotlight on the importance of addressing soil health and combating desertification and water scarcity is very, very good and much needed. So thanks for your great work.
Before you stop listening, ask yourself, what are one or two useful things you heard on this podcast that can help you overcome food and fertilizer shortages, skyrocketing prices, the cost of living, or your job being outsourced overseas or eliminated due to automation? Please like and subscribe and tell your friends and family about their Surviving Hard Times podcast. We're all going to need help now and in the near future.